Hey y'all, so in this video we're going to talk through solving a system of equations by graphing. We'll also look at systems of inequalities. So to start us off, basically what we want to make sure we do when we're graphing things by hand, a lot of times we put things into slope-intercept forms. That's y equals mx plus b, where m is our slope, the rise over run, and b, the number on the end, the constant, tells us our y-intercept. So if I were to graph this line, we'd see that it would cross the y-intercept at 2, and it would have a slope of 1/3, meaning we'd go from 2, we'd go up 1 unit. Let's see, we're at 3 here, so up 1 unit and over 3. Cool, so we see that slope of 1/3, up 1, to the right 3, because we're in the positive direction. Similarly, on this other line, we could see we could start at 7, that's our y-intercept. This time we have a slope of 2. So when we see a slope of a whole number, we can think of it still as rise over run 2 over 1. So from this point, we could rise 2 and run 1, right? Or we could go in both the negative directions. So down 2 and then back 1. Those two negatives come out positive. So a lot of times we want a system of equations to help us solve some problems. So when we're trying to find a solution to two equations at once, it's really easy to do if we throw it on the graph. Here you can see there is one point where these two lines intersect. So that one combination of x's and y's, so if x is -3 and y is 1, that'll solve this equation, the purple line. The line is, or the point is on the line, and it'll also solve the green equation as well. So solving by graphing is one of the easiest ways to find the solution to a system. Cool, so let's take a look at doing this by hand. So three things can happen when we're solving a system of equations. So most of the time we'll have a single intersection point, so kind of like what we just saw. So here we only have one solution, and just like we saw earlier, our solution is some point, some combination of x and y, right? That solves both both equations at once. We could also have a situation where our two lines have the same slope. So if this also had a slope of 2, then we'd see two parallel lines. These lines will never, ever, ever intersect. So we have no solution. There is no combination of x and y. There is no point that solves both. So this would be a no solution. And finally, sometimes we'll actually have the same line on top of itself. So this is a little weirder, but we could have something where we can't quite tell just by glancing at this that these two equations are the same, and they're not. There we go. Cool, so you might not notice that these are the same equation. I've just doubled everything. But actually, these two lines are on top of each other, right? You can see they're the same line. So here we would have infinite solutions because every single point that's on these lines is a solution. So if we have two lines on top of each other, it's kind of hard to see there, we'd have infinite solutions. Okay, so let's try this out. We've got y equals x minus 8. So we always start with our y-intercept. This is in slope-intercept form, y equals mx plus b. So we don't have to do any hard algebra here. It's already solved for us. But I do need to start at my y-intercept at -8. And then my slope, we just have 1x. So our slope is just the number attached to x. In this case, is just 1. Or as I like to think about it, because I'm thinking rise over run for my slope, 1 over 1. So from that point, I'm going to go up 1 unit and forward 1 unit. We've got a ratio of 1 to 1. For every unit we increase in the x direction, our y is going to increase 1 unit as well. That was kind of a wonky line, but it'll work. All right, let's take a look at the next one. So for this one, we've got, again, we're in slope-intercept form, so nothing to solve. We have a y-intercept of +1, and then we have a slope of -2. And again, we can think of it as -2 over 1, so we can think rise over run. So down 2, over 1, down 2, to the right 1, and boom, there's our point of intersection. So I'm going to sketch this line out. I'm doing my best to get a straight line here. It takes a lot of time to get the ruler up, so we're going to go with it. Okay, so there's our intersection point. So let's see where that point is. We got 1, 2, 3. So 3 in the x direction. And then down 1, 2, 3, 4, 5. So -5 in the y direction. So there's our answer, 3, -5. So notice your solution to a system is always a point, right? A combination of x and y that solves both equations. Let's look at another. For this one, we got to work a little harder. This first equation is already solved for us. It's in slope-intercept form, 1, 2, 3, 4, 5. We've got a slope of 1 again. So again, our slope here is just 1. So we can think 1 over 1, rise 1, run 1. And that's our line. Okay, for the next one, we're gonna have to do a little work. So this isn't in slope-intercept form, and it doesn't mean we can't graph it using this form, but most of us are used to using slope-intercept. So I'm gonna go ahead and solve this for y. So that's easy enough to do. I've got this x here that I don't want, so I'm gonna subtract x to move it to the other side. So that leaves behind a -y, and then we got -x plus 2. Notice I'm putting the x out front just because that's our standard form, or our slope-intercept form. And then I've got -1y. So this negative we can get rid of by dividing everything by a negative, or just changing the sign. So we get y equals x minus 2. So we start at -2, that's our y-intercept, right? That's the number on the end. And then our slope again is just 1. And our slope is the same as the other line. So that should tip you off right away that these are our parallel lines, right? I can show that little symbol here. These two lines have the exact same slope. So they're never going to touch each other. And if those lines never intersect, then there is no combination of x and y that will solve both equations. So we have no solution. Okay, what I'm going to do next is take a look at solving a system of inequalities. So we had equations there, but over here on the right, we're going to have inequalities. So let me take a look at one of these. Okay, so neither of these are solved for y, so we got to do a little bit of work first. All right, that's okay. I'm going to take this first equation, x plus y is greater than -1, and get y alone. So this is easy. We can just subtract x. We got y is greater than -x plus 1. Oh, sorry, minus 1. Okay, we can take that other equation. This one's going to be a little bit more work. X minus y is greater than 5. Okay, so we're getting y alone. Again, we need to get this x term out the way. -y is greater than -x and 5. And then we want to get rid of that negative, just like we did in the last problem. So I'm going to divide both sides by -1. But you have to remember, when we're dealing with inequalities, if I try to divide everything by a negative, I can still do that, but it's going to flip my inequality around. So don't forget that little rule there. Okay, so we got our two equations there. So I'll do pink since I'm in that color. 1, 2, 3, 4, 5. So intercept of -5 and a slope of 1. So the process for graphing these is pretty much the same, except here, instead of using a solid line, I'm going to need a dashed line or a dotted line, which we can do. Remember that if we just have got a little bit off there, but that's okay, it's just a sketch. If we have a less than, we use a dashed line. If I had a less than or equal to, then I would use a solid line. Now lastly, we want to make sure we shade. So y is less than, which means we're going to be shading below. If you're unsure about which way to shade, and sometimes it can be a little tricky, you can always just plug in a point and see, does it solve the inequality? If so, that point's in the shade. Okay, and let's do the green one as well. So I've got -1 as my y-intercept and a slope of -1. So down 1, run 1. Okay, and again we need a dashed line because we don't have the or equal to. Try to stay on the line a little bit better. If I were doing this on paper, I'd use a straight edge and my lines wouldn't be so bad here. Okay, this time where y is greater than, so we're shading above this line, and I didn't finish my line. I know it's a little sloppy, but that's about as good as I can do using this little pad. Okay. So we shade above the green line, we shade below the pink line. And now this is getting a little bit messy, but what we see here is we have this area right here in the middle that has both the pink and the green. That is our solution set, right? Any point that is solving both of these inequalities at once, aka is in both the shades, the overlapping shade, that is our solution. So you just want to make sure when you're doing this by hand, you want to make sure that that area is much darker than the other ones. If I were using a pencil, something where I can control how hard I'm using, this doesn't do so much. I do nice light shade over here and dark shade over there. So any point in there solves the system, right? I could choose any of these points and it would work for both of these. Okay, these can be a little tedious and there's a lot of places to mess up. You could have forgotten to flip your sign, you could have dropped any of these negatives, lots of different things could go wrong. And then when you're actually plotting it, right, another place to go wrong. So I want to encourage you to use Desmos for something like this. So for this one, I'm going to just throw this into Desmos and, oops, and we can take a look at our solution that way. So here we have our two equations, x minus 4y is less than or equal to 24, and 2x minus y is greater than negative 1. So you can see we've got both graphed here, and we have this area that has both the red shade and the blue shade. So that overlapping shade, that is our solution. Okay, that's pretty much it for today's lesson. We'll use this to start doing some application problems next time. Cat.